Okay, we start up again. I had to restart my parafoam one reason or another. I don't know why he just displayed it in the center region. Of course, you should have an image something like that, like this. And if you want a mesh in the background, yeah, you can do that. Switch that one on. Wireframe with a solid color. And then you should, maybe we should have it in 2D. Like that. That's what he doesn't like. Okay. Well, let's turn on the parallel projection then. He doesn't like that either, stupid machine. Okay, so leave it. Anyhow, yeah, but the colors were not the best. Should be a little bit brighter. You can play around with this setup for yourself, but at least here you can actually see it quite clearly, especially if you then remove the mesh. It's quite obvious he has some trouble here. That shouldn't be there. That's your job in exercise 4. Fix it. It should be parallel lines for the pressure gradient when it's fully developed. Your job. Same for the velocity. Let's see now. What did we have to do? Yeah, that was that calculators thing, wasn't it? Let's see now. Recent. No. Calculator. Here we are. Shouldn't take too long. Where are we? Result, fair enough. And then we had square root of ux plus uy squared. Something like that. And then we could add another contour. And then choose result, choosing a whole bunch of samples here, 40, generate, apply. So, maybe a little bit too much. But again, you see we have some trouble here in this merge region. Fix it. Fix it. Okay, that was contour plots. I think you can do a lot here, changing colors, changing the line thickness, rather heavy actually. And yeah, you can do a lot of things. Your choice. Next was to create a mesh. Looking something like this. Now we're talking snappyHexMesh. Sadly, snappyHexMesh is not for amateurs. And no, you don't set up a snappyHexMesh case from scratch. Just forget it. Find a tutorial that does something that you want, and then change it to your need. So yes, we will have a look at this one. See if we can make that one work. Now, at least on my machine, I did find a nice tutorial. I think I have, let's see now. Here we are. Yeah, it's removed, thank you. I want to copy a tutorial. And in my machine is under user, lib, open foam tutorials, incompressible. And under incompressible, then under actually it's called pimple foam. Pimple foam. And under pimple foam, we had a turbulent case, which was called wing motion. So that one I want. W. So I'm going to copy this case. Wing motion. Wing motion. Big M. Wing motion. So here we have a setup, obviously, for something. A little bit strange setup. You don't have the zero and the constant and the system folder. Instead, you have 3 different subfolders with 3 different cases. So what the heck is going on here? And this is something you always should do when you then have stolen a tutorial from somewhere. If they have an old run file, have a look at that one. Maybe even also the old clean. So let's check it out. Let's see now. I'll get rid of this. And then we have a look at gedit all run. And here, these all run and all clear and whatever all files you may find. I mean, they are just instructions, scripts, a shell script. So somebody who has created this one has sort of programmed it for you. And here you can actually see step by step what he's going to do. So if you look at the start, he will first jump into this folder. And then he will make some tri-surface directory, copy a file into that directory. And this is going to be actually a compressed file. No secret, this is actually an STL file or something like that for a wing profile. Then he's going to create block mesh, and then he's going to run snappyHexMesh in that folder. Afterwards, he's going to create a 2-dimensional mesh. And this is something that can be a little bit tricky. Using snappyHexMesh is always 3-dimensional. I mean, OpenFOAM by nature is 3-dimensional, but you can still use 2D cases by just choosing one cell in the Z direction. But when you're using snappyHexMesh, you always get a 3D mesh. You can cheat then, or simplify it, by extrude mesh from 3D to 2D. Yes, that's possible. You need some additional step here, a create patch, something like that. And then actually here he runs SimpleFoam, a steady state setup, on this 2D case. And then he continues. So this is quite advanced setup, this one. Then he goes to the wing motion pimple foam. Pimple, that is turbulent and transient. So, okay, he removes the entire mesh and then he copies the mesh from the previous case. And then he's going to use map fields. What does map fields do? He can take a solution from one simulation and map it onto another case. Well, now the mesh is going to be the same, so that's fair enough, not a problem. And then he's going to split it up. He's going to use more than one CPU and run in parallel. And believe me, if you do this, be prepared that your PC is really going to struggle. This is going to take many, many hours producing gigabytes of data. You actually have a wing that is moving in time. So it's a very tricky setup. Now for us, I would say we don't really need all this. So I could actually then just destroy that one from this old run file. Now I'm not going to run this file anyway, so never mind. What about the other one? All clear. That was a little bit easier. He clears all the 3 different cases. So clean case from the 3 different folders. So that's his job. Well, he's not so important. But then let's just try this step by step and see what we can get out of this. So the first step, we have to go inside this, no, where are we? Here, this snappyHexMesh folder. So let's do that. Here we are. CD, what was it called? Wing motion underscore snappyHexMesh. So here you will actually have only the system folder. That's a little bit weird, isn't it? But remember his job for this, this folder here, that's only to create the mesh. He doesn't need the 0 folder. He doesn't need the constant folder. Only inside the system. And if you look inside that system, well, we have some files here. Block mesh dict, of course. We're going to need that one. We need a control dict. It's decomposed par dict. That is for using more than one CPU. And then the standard F3 schemes and F3 solution. And then we have a snappyHexMesh dictionary. That's the instruction for snappyHexMesh. And believe me, that one is not trivial. But let's do this blindly first. Let's see now, what should we do up here first? Well, he says we should do this, and oh, it's way too much to write. Let's do it easy here. I destroy the last part of this setup. Save that one. Going back. And then here. I'm back in the main folder with my all clean, all run and everything. So now let's execute this all run thing. Shouldn't take too long, I think. All run. To execute a script, you typically have to write period / and then the name. You can't just write the name. Depends on the system, but I at least have to do it like that. So now he's executing this one. First he creates, runs the block mesh, then he runs the snappyHexMesh. Can take a little time actually. Let's see, it shouldn't take too long. Here we go. And then extrude mesh, create patch, restore, and then he's now running simple foam. And that one shouldn't take too long either. Ah, come on. Let's crash it. I don't care. So at least he has started. Let's have a look what he has done. First, let's go into this first folder, the snappyHexMesh folder. What did he do? Originally, he had only the system folder, but he should create the mesh initially using snappyHexMesh. Hence, he has created a constant folder, and inside that one, you should then find both the poly mesh, and you find something called a try surface. That's where your images is going to be stored when you're going to create a mesh around, say, an object or something. Let's have a look at the mesh here. That's actually possible. So here we have our setup, and yes, you have a tiny little airfoil inside here. Very good. Let's have a look at the mesh. Surface with edges. Okay, there you see what he has done. Really resolved say, the area around this airfoil. Finer and finer and finer and finer and finer mesh. And if you really zoom in here, Let's see. Some say at the leading edge. There you can see what he has done. He has even provided us with some nice layers very close to the surface, so that you may reach a nice Y+. So this tool is actually quite strong. It's actually quite strong. Sadly now, this mesh is three-dimensional. And here we are only interested in a two-dimensional case. So you see he has plenty of cells here in the Z direction, which we don't need. We don't want them. So the next step then, that was the second part. He then run what's called an extrude mesh. That one can take one mesh and then patch it or glue it or change it to something else. Extrude mesh from 3D to 2D. That's possible. Create patch, that's something also has to be done, because the original mesh, you need an inlet, outlet, wall, symmetry line, whatever. They have to be preserved, and then especially the front and the back. I mean, in a 3D case, they will be either symmetry plane or whatever, I don't know. But for a 2D case, they should be empty. So they have to be created. That's his job. And so here, in this folder, let's have a look at the mesh again. Let's see, where are we? And then we have the wing motion, and then it was the 2D simple foam thing. Yeah, I crashed him, but you see he started to simulate, so we have a whole bunch of result folders from simple foam actually. So let's have a look at it. Let's see now. Parafoam. So the mesh now actually is roughly the same. You can't really tell the difference, can you? But let's zoom in here a little bit. Zoom in a little bit more. Here. Now you see what has happened. You have the same mesh in the 2D structure, but look at the Z direction. One cell. Beautiful. Now I have a two-dimensional mesh. Beautiful. And then if you want to have a look at the solution here, you have the velocity. Well, we don't need the surface with edges anymore. And yeah, you can play it here. Play. Not so impressive. I don't think he has converged anyway. And yes, you can have a look at the pressure. So why does a plane fly? Well, you have a low pressure over the wing versus high pressure under the wing. You get a pressure force, you get a lift force out of that one. So there you have it, sort of the setup for such a case. Any questions to that one? Then we are going to dive a little bit into the details here. So hold on to your horses. Say now I want to change this setup. Where should we start? Wing motion. That was first the snappyHexMesh folder. That was the first step. So inside that folder, what did he do? First, he run block mesh. Let's have a look at that one first. The block mesh dict. And as you can see, very simple setup. 8 corners, and you have one single block, uniform mesh. This is going to be the background mesh, where you say want to put in an object and you want to have snappyHexMesh creating a nice close mesh around this surface. But you need a background mesh. And quite coarse actually. But here, something to pay attention to, your cells should be roughly square. So don't have a high aspect ratio. They should be close to squares. But that's it. That's it. Maybe here, if you look at the boundaries, can be a little bit strange maybe. Top and bottom, they are type patch for now. Inlet type patch, outlet patch. And then we have the front and the back set to be symmetry planes. So that is sort of the start mesh that he's going to need. Symmetry plane in 3D, because it's going to be three-dimensional no matter what you want. Although you have only specified one single cell in the Z direction, but snappyHexMesh is going to overwrite that anyway. So just the background mesh. Nice uniform background mesh. Then we run snappyHexMesh, and he has his own dictionary. And this one, ooh, they can be hard to understand, to say the very, very least. So as I said, you find one of these from a tutorial and then you change it to your needs. So here, for instance, now they have set up something which we don't even want to know about, at least not now. And here we have a geometry. They have this 5-degree attack angle for the wing from a file. It's actually called an, here is now an object. And they have a refinement box around that one. Fair enough. This refinement box, yeah, we could use that one. Of course, here you can then put in something else if you want to have a flow around something else. Yeah, that's fine, actually possible. And then you have a lot of parameters. Here also we have the access to the same object, the wing, and then sort of a refinement surface, 5 by 5. And we have this refinement region. And here you can say we wanted the refinement to be inside that box. You could actually choose outside. That's another option as well. Never mind. And what else do we have here? No, I don't think we need anything else here. Well, we have something here in the end. The layers. That was the resolution for the boundary layer, very, very close to the surface. So here you can specify how many layers you want. You can even have an expansion ratio for this number of layers. And even finally layer thickness and the minimum thickness. You can specify a lot of things here. So definitely some parameters you can play around with. Let's see now, mesh quality control. Yeah, normally you shouldn't mess around with this one until you know what you are doing. Of course, play around with them if you want and see what happens, but don't destroy it completely. Now that was the snappyHexMesh dictionary. Did we have something else here? Actually, no. So that was all that you need for 2 steps. Create the background mesh and run snappyHexMesh. The next step, that was maybe a little bit more messy. Let's have a look. That was the case for 2D simple foam. And here we had in our system some additional files. What did we have to start with here? Well, we had to extrude the mesh. And to extrude the mesh, you also need then a corresponding dictionary. Where do you find the case, the mesh to be extruded? And you have some parameters here that you can play around with. Here we don't really need to change everything, and we don't need to change anything here. You can specify the thickness for the Z direction here, and you only have one layer, of course. We want a 2D extraction. So that was the extrude mesh, and then we have the create patch. He should then fix our front and back system to a 2D case, and yeah, we don't need to mess around with this one much either. So that one should be, I think we can leave him untouched for now. And that's it. That's it. Now to show you, I have changed this case. Let's see, where are we? Should be here, I think. I'll copy this case out for you on the homepage so you can have a look at it yourself. So I've stolen this wing motion setup, but I've changed it a little bit. Let's have a look. First it was this snappyHexMesh thing. And then it was the system and the block mesh dict. So I kept the mesh and I didn't change anything here, but in the snappyHexMesh dict, here I did something. I removed the wing. I took away this object. And for a refinement box, I now changed it from type box to a type sphere. You have several options here. You have a lot of, say, basic geometries you can put in, cylinder, rectangles, whatever. And then I said radius 1, and it should be placed in this location, X, Y, Z, yeah. Sort of in the center of this mesh from the block mesh dict. Furthermore, I then had to remove something here. This refinement surfaces. I don't have the wing anymore, so I just comment that one out. Shouldn't be a problem. And then that one has kept. What else do we need here? And layers control. Yeah, here is also something that had something to do with the wing. I just commented out. I don't want any layers anymore. These constants here, they will sort of describe how this boundary layers should be treated. So they don't do anything, but it's not wrong to keep them there either. So I just keep them there. So now let's try this one and see what happens. Don't think there was anything else. No. We try. First of all, I'm going to need this file, this all run file, so I know what to do, because this was sort of the recipe. So let's try this one now. So I'm standing in the correct folder, the snappyHexMesh folder, change directory to that one. Then I skip this part. I'm not going to make a surface around the wing, so I don't need that one. But I need the block mesh. So let's run that one. Block mesh. There we have it. And this is then just a very, very simple mesh, paraform. So there you have it. Uniform background mesh. Cells should be close to squares. No high aspect ratio. And you see it's a 2D case. So that was that one. What's the next step? We should execute this snappyHexMesh minus overwrite. So let's do that. snappyHexMesh minus overwrite. There we go. It does a lot of things. Actually, for a big complex problem, the snappyHexMesh program, it can take a long time. That's often why they sort of prepared it to use more than one CPU, but depending on how big the problem is, of course. Here, it's not that big. So what has he done? Let's have a look. Let's have a look. Now I removed the wing. The wing is gone. But what about my mesh? There you see it. I put a sphere in the center. And I told him, refine the mesh inside this sphere. So it's not a real sphere with a, say, a solid wall. It's actually just a region in space where I told him, refine the mesh there. And now when I simulate, the flow is going to go straight through it. So this can be nice to know. Say if you have a case where you have in some region in your domain, you have a very strong gradients. A lot of things happen just there. You want to refine the mesh just there. So instead of using stretching, block mesh dict, whatever, this would be one way around it. snappyHexMesh, refine the mesh in that region, done. But of course you see the mesh is not that nice actually. It has some, what should we call it? Some structures here. If we go to wireframe, it's not easy to see. Quite messy mesh actually. And also now remember, this is a three-dimensional case. You can't run this on 2D. It's not possible. We have to extrude it down to a 2D setup. So it looks to be two-dimensional, but it's not. So sadly, we have to continue then with the next step to extrude it and then also create this patch front and back. I think I've done that already. Let's have a look. See the, what was that one? That was 2D simple form here. So we have a 0 original. They typically use it like that. So when you want to simulate, you have to copy that one into just a 0 folder, but never mind. And here we were supposed to do what? First, just run extrude mesh. Okay. Then we run extrude mesh. Like that. So now we sort of have extruded the 3D mesh into a 2D mesh with actually quite small thickness. So small that it's actually hard to see it. And then finally create patch minus overwrite. I can copy that one and just paste it in here. He then just creates my patches that I'm going to need in the end. Front and back and everything here, so that I have all that I need. Let's have a look at the mesh now. Parafoam, apply. So here now we should have a 2D mesh. You can hardly tell the difference from the mesh that we had after snappyHexMesh, but it's really thin here. Isn't it possible to have a look here somewhere? Yeah, it's a 2D mesh. And if you're in doubt here, say, remember here in the end, you're going to simulate. You have an inlet, outlet, walls or up and down or front and back and whatever, just to make sure that you have everything right for the mesh. Then you can go down here and have a look at the mesh regions. He only shows me here now the internal mesh. Let's get rid of that one. Do we have any empty meshes? Yes, we have. What's the empty meshes? That's front and back. You can hardly tell the difference. Okay. Then what about the back only? Yeah, makes sense. And again, the front should be identical. Yeah, looks okay. What about the inlet? Well, we can take the outlet and the top and bottom as well. There you only see the cells belonging to inlet, outlet, up and down. And yeah, makes sense. So that is a nice way to sort of have a control of the mesh in the end before you even try to simulate it. So my point was, for this exercise that I have given you, yes, create a stupid mesh, something like this. For this case here, laminar flow fully developed between two parallel plates. This is extremely stupid, extremely silly. We don't have any special gradients in this region, so it's just a waste of time actually. The problem is, we know the solution, how it should look, and this strange distorted mesh should not sort of destroy your solution. OpenFOAM should be able to handle it, but there you may have to play around with some additional steps in the OpenFOAM setup. Non-orthogonal correctors, do some extra iterations here and there, fix it. That's the job for exercise 4. Okay.